Calculus does not merely consist of dry functions or formulas, but it also has an intriguing history of development, associated with many well-known figures in mathematics. The history of calculus can be divided into three main phases: anticipation, development, and rigorization. The anticipation era started in ancient times and developed through centuries with the contribution of many mathematicians like Archimedes, Galileo, Descartes, Fermat, and so on. However, not only until Newton and Leibniz published their works about derivatives and integrals, did calculus really start to bloom and play a significant role in studying maths. Even though the owner of calculus is now credited to both these two great figures, it is not enough for them and their supporters. Therefore, even nowadays, the question, who is the father of calculus, Leibniz or Newton, is still a big debate. In fact, the first person to explore the core values of calculus was Newton in 1665, when he called it the science of fluents and fluxions. But the first to publicly introduce the term calculus with a clearer explanation was Leibniz, in 1674, roughly a decade later than Newton. The two different names also reflect how differently they approached to calculus. Newton first began from his strengths in physics, motion and geometry, then discovered fluxion, which is now derivative. Leibniz, on the other hand, was more mathematical and dealt more with differential, especially infinitesimal differences. Their differences clearly manifest through the notations they used to illustrate their methods in calculus. Newton's papers are usually messy, so the notations often vary. He simply interprets the variables as fluents, that change in time at a rate known as fluxion, which is derivative, and he denotes the derivative of x or y with respect to time, t, as x dot and y dot. For higher derivatives, he would use more dots. For the derivative of y with respect to x, it would be written as y dot over x dot, a simpler form of what is now known as dy over dx. For the integral, he would write it under three forms, which are small prefixing rectangle y, y inside rectangle, or y with prime above. Leibniz, on the other hand, had a more complete and consistent system of notations which is still used until modern day. For differentiation, he writes it under the form of dy over dx or d over dxy. Higher derivatives can be written as d square y over dx square, d cube y over dx cube. Sometimes, he would use a line above the differential, which covers the terms that are about to be differentiated. For the integral, Leibniz is the one who brought in the notation of a long s, standing for summa in Latin, which means sum. Since the integral can be understood as the sum of the infinitesimal rectangles under the curve, it has the symbol of sum. Despite approaching the ideas from different directions and methods, Newton and Leibniz shared some similarities. They all made use of infinitesimals, which are infinitely small quantities but different from zero. Besides using this terminology in many papers and calculations, the two figures also used graphs to interpret calculus. They did not interpret calculus geometrically in a vague manner as mathematicians in the previous historical period, but they combined algebra calculations with geometry to make a clearer analysis. Both Newton's and Leibniz's works still have flaws with irrational reasoning about certain problems, especially the infinitesimal concept. Therefore, what mathematicians like Cauchy, Lagrange, and Riemann in the rigorization era attempted to do was to justify their errors, and finalize the basic principles of calculus. Since the introduction of calculus created a significant influence on the mathematicians' community, there were numerous debates and rumors about the calculus wars between the two figures. While some Newton supporters accused Leibniz of being a thief, as the German mathematician might have read some of Newton's private papers about calculus. Some believe that Leibniz was in fact the legitimate father of calculus, as he was the first to publicize the ideas, and blame Newton for making up the entire drama to reclaim his glorious past fame. Despite all the gossip surrounding them, both Newton and Leibniz deserve the title father of calculus, for their breakthroughs in this branch of mathematics. They are the twin genius founders of calculus.